We want to look at some equations now that contain multiple angles. I want to find all degree solutions to the equation sine 2 theta is equal to 1/2. Well, I know that this angle, if it's going to have a sine of 1/2, is going to be 2 theta equal in degrees 30 degrees plus any multiple of 360 degrees. So I'll say 360 degrees times k, where k is any integer. So once I have 30 degrees, if I add on one period for the sine function, I'll get other solutions for that. Now I have a second solution. 2 theta is equal to, let's see, sine is also positive in quadrant 2 with a reference angle of 30 degrees. That's going to be 150 degrees plus any multiple of 360 degrees. So these are my solutions, all solutions for 2 theta. To find the solutions for theta, I just divide by 2. Theta is equal to 15 degrees plus 180 degrees times k. There's one set of solutions, and then here I'll divide by 2 also and get 75 degrees plus 180 degrees times k. Now at this point, if I wanted to just find all my solutions between 0 and 360, I would substitute in values of k, starting with k equals 0, then going up to k equal 1, then k equal 2, into these equations until I got out all my solutions between 0 and 360. So when we have these multiple angles like this, sometimes it's easier to find all solutions and then go back and find your solutions between 0 and 360. Let's try another problem. We want to find all radian solutions this time to this equation. Sine 3x cosine 2x plus cosine 3x sine 2x equal 1. Well, this looks like my expansion formula for the sine of a plus b. So I'm going to write this as sine of 3x plus 2x is equal to 1. Now I'll simplify this by writing it as sine 5x is equal to 1. And now I'll say, well, 5x must be, okay, in radians, pi over 2. That's 90 degrees, and the sine of 90 degrees, or sine of pi over 2, is 1. That's all the solutions between 0 and 360. And then I'm going to add on multiples of 2 pi. So I write it like this, 2k times pi, 2k times pi. So there's all my multiples of that period, 2 pi. So I have one solution here between 0 and 2 pi, and then I add on all the multiples of 2 pi where k is an integer here, and I'll have out all solutions. Now I don't want 5x, I want x, so I need to divide both sides of this equation by 5. So x is equal to pi over 2 divided by 5 is pi over 10 plus 2k pi over 5. Now, for any integer value of k that I put in here, I'll end up with a solution to this original equation right here. So finding all solutions actually turns out to be a little easier than just finding solutions between 0 and 360. You find all your solutions through one period, and then you add on integer multiples of the period, and you have all solutions. Here's our next one. I want to find all degree solutions this time to 2 sine squared 3x plus sine 3x minus 1 equals 0. So I'm just going to start by factoring this into 2 sine 3x, sine 3x, 1 and 1. Inside is 1 sine 3x, outside is 2 sine 3x. I want that middle term to come out to be positive sine 3x, so I'll make that positive and that negative. I set this factor equal to 0, and I have sine 3x is equal to 1/2. I set this factor equal to 0, and I have sine 3x is equal to negative 1. So here, sine 3x is equal to 1/2. We did that problem previously, and we get 3x is equal to 30 degrees plus 360 degrees times k, and we get 3x, did I write down too low? 3x is equal to 150 degrees plus 360 degrees times k. Divide both sides by 3 here. I have x is equal to 10 degrees plus 120 degrees times k. There's one set of solutions. Divide both sides here by 3, and I end up with x is equal to 50 degrees plus 120 degrees times k. There's a next set of solutions. I'll go over here to this. Sine 3x is equal to negative 1. That means that 3x is going to be equal to 270 degrees. There's my one solution between 0 and 360, plus 360 degrees times k. Divide both sides of this by 3. X is equal to 90 degrees, plus I'll divide that by 3, 120 degrees times k. So there's another set of solutions. So all solutions to this equation right here are contained in this expression, and this expression. All three expressions together give us all solutions to this equation. So there's a quick look at solving equations that involve multiple angles.